Yes, myself Priya, Assistant Director from National Skill Training Institute, Bangalore. Yesterday I discussed about an operational amplifier. It is about the op-amp IC 741, and today we are here to discuss about the continuation of yesterday's part. It is timer IC. It's timer IC 555. So this is present in your ITI syllabus, and as well as this is present in your CITS syllabus for the electronic mechanic trade. Uh, Please, some more participants are ready to join. We will accept everyone. Yes. Yes. Okay. Okay. I hope the screen is clear to everyone. Uh, so timer IC, timer IC 555. So we all have the idea of timer. So many of us from this group might have played with this timer, isn't it? So it is for solving a simple max or solving the jumbled letters. We might have used this timer. Yes, correct. We will also see a few more places where we can identify this timer in our real life. So daily we set alarm in our clock, and that is also a timer. But actually, all these are software timers, not the hardware timer. But what we are going to discuss about is the hardware timer. Not hearing my voice? Not hearing my voice? Please, someone can chat. Okay, okay, thank you. Yeah. Yes. So where you can see the timer. See, this is one of the industrial application I have taken where you can see the real timer. So this is one food processing unit or a cool drinks manufacturing company where they are doing different stages of cool drinks, different process involved in making cool drinks. So here they have the conveyor belt to allow the bottles one by one, and in at a particular time, I'll take a laser just a minute. Okay, at a particular time, the bottle comes and waits near the filler for a particular time to fill up to the complete brim of the bottle. So here comes the application of timer. Then slowly our conveyor starts to move one by one, and here one more bottle holder is there to pick the bottle and place it in this carton box. So all these are the places where we use timer. So the bottle has to come in the conveyor belt. It has to wait for the respective time to get it filled. So here comes the application of our timer. So this is one of the industrial application of timer where you can see the timer. So apart from that, in our home domestic place where I can see the timer, uh, can we see the timer in the geyser for the heater to heat your water? Yes, correct. So when we switch on the geyser, it will be on for a particular time, and once the water is hot, then automatically the system goes to the heater goes to off state, isn't it? So many of you might notice, all this. Yes, correct. So this is the very good application of timer. Yeah, in streaming iron box. In iron box also you can see the timers. There are so many places. So many places you can see this timer. And even in my kitchen also I can see some of the timers. Yes, the microwave where I set the time to bake my cake. That is also a timer, and not only in the kitchen where we send rockets to the space. That also involved with the timer. Yes, you are very correct. We will start the timings 2 days before we launch a satellite, and the countdown keeps on going on. The countdown keeps on going on. So that is also a timer again. So this is where these are all the places where you can see timer. Yes, and we all have one timer. It is an internal timer. Usually we call that as a biological timer. That is, yes. So when tomorrow you have the exams, and today night while sleeping, you all will be thinking, yes, yes, correct. At 5 o'clock exactly, I have to get up to prepare for the exams. Yes, no. So you all sleep with the thought, and exactly at 4:45 you wake from your bed, isn't it? So that is our biological timer. So we have priority to set our timer. We can ourselves set our timer. So we can also activate the timer. Timer is not only the external thing or a external machine or external device. The God has given us also some internal timers, biological timer, which will activate whenever required. Yes, is it clear? What is timer and why timer is required, and what are all the different places you can see timer? Yes, correct. So shall we go to the next slide? So timer. How it works. So it's very clear. Timer is there everywhere. Timer is there everywhere. But how it works actually? Any logic is there in this? Yes, it's a very simple logic. It's a very simple logic for the timer. It's not as difficult as the rocket science. Yes, it's very simple. So I have one voltage source, I have one resistor R connected, I have one capacitor C. So we all know that the capacitor will charge and discharge. That is the main thing of capacitor. So what the capacitor will do, when I apply voltage, the capacitor will start charging. When the switch is in position 1, the capacitor will start charging. Yes, no? Through what? Through the resistor R, the capacitor will start charging. Yes, correct? So how long it takes to charge? How long the capacitor takes to charge, take time to charge? The time is decided by my resistor present here. If I take a large value of resistor, then my capacitor will take more time to charge. If I take less value of capacitor, my if I take less value of my resistance, then my capacitor will also take very less time to charge. Yes, so the charging and discharging of capacitor is decided by whom? Is decided by the resistor what I have. So it's the circuit is very simple. We have only one R and one C present here. Yes, okay. So when I put the switch in position 1, it starts to charge the capacitor through the resistor. And when I put the switch to the position 2, there is no power source connected here. So my capacitor starts to discharge in this path. I'll take a pen. Just a minute. So when the switch is in position 2, the capacitor will actually starts to discharge like this. Yes, okay. So we charge the capacitor, we discharge the capacitor, and it takes certain time to charge and discharge the capacitor because of the resistance present here. If the resistance is large, it takes more time to charge. If the resistance is small, it takes less time to charge. Yes, okay. So the time tau here is the time required to charge the capacitor or to discharge the capacitor. So tau is equal to R into C, the value of R and as well as the value of C. Yes. So time constant will be more if you have more value of resistor, and time constant will be less if I have less value of resistor. Yes, okay. So it's not that rocket science. It's very simple to understand the logic of um, timer circuit. So now we focus on only these major topics, how my timer basic circuit will be, and what and all the basic blocks required for this. Then my topic is specific for IC 555, no? So we will see the pin diagram of that, and then the block diagram of that IC 555. Then its modes of operation, mode of working, two mode of working, and two applications, PWM and PCU. Yes, these are the things. So I'll explain you the terms if you are new to this. If you are just fresher first year, these terms will be explained in detail. Don't worry. Yes. So we will observe, look into this. We will look into this basic blocks of timer. Basic timer blocks. Only there are three important blocks present here. The first one is the charging unit. As we already know, the charging unit consists of very simple one resistor and one capacitor. So that is my charging unit. And second, it has a comparator in it. And we know comparator, what it is. In yesterday's class, we discussed about this comparator. And the last unit is the output unit. Yes. Um, so we discussed like there is a time, there is a trigger. We discussed like we have a biological clock. So that clocks wakes at, if you want to wake up at 5 o'clock, that clock will wakes at exactly at 5 o'clock. Yes, isn't it? So that we call that as trigger. So I want to wake my biological clock at 5 o'clock. I set a trigger. I tune myself that tomorrow I have exam, so at any cost I have to wake up at 5 o'clock. So that is my trigger here. So if I trigger, this trigger is applied to the comparator, and then it will do certain operations, and then it pass to the next unit, and then finally we will get the output. Yes, got it? So what is there in my charging unit? As we discussed earlier, we have a resistor and we have a capacitor in our charging unit. So just see, when you press the trigger button, the trigger button is a push button here. When you press the trigger button, so what happens? The capacitor present here will start to discharge. The capacitor present here, oh sorry, the capacitor present here will start to discharge via this trigger switch. Yes, isn't it? Or if I release the trigger switch, then it cannot able to discharge, but the capacitor start to charge via this resistor. So this is how the trigger and the charging and discharging works in the charging unit. So whenever I push the trigger switch, my capacitor will discharge. If I release the trigger switch, my capacitor starts to charge. Yes. Then the same signal, the capacitor voltage is applied to my comparator. Yes, isn't it? The capacitor voltage here is applied to my comparator. So now this will be available at this point. The capacitor voltage, what I give as output here, will be available at this point, and this point and this point will now be compared by the comparator. Yes, yesterday we discussed about what is comparator. We discussed two different types of comparator. One is a simple comparator, other one is a zero crossing detector. Whenever it crosses zero, the state changes to 1, changes to 0. Yes, so all participants, you can able to recall the concepts what we discussed on the yesterday's class. So in one point, I have the output of capacitor voltage. So capacitor voltage reaches a particular value, and the other point I have some reference value. So it always compares these two. And whenever this point is greater than this point, it gives the output. The comparator goes to one state. If the comparator goes to one state, then immediately the output starts to release. Yes, so here see, I'm applying a trigger. So after applying the trigger, the capacitor starts to charge. Charge up to which level? Charge up to the reference level. Only up to the reference level it can able to charge. Am I audible? Am I audible? Please reply in the chat box. Okay, thank you. When I apply the trigger, the capacitor discharges completely. The capacitor discharges completely. It is discharging, and again it starts to charge. Charge up to which point? Charge up to the reference point. So once we reached the reference point, the comparator output, what happens? The comparator output changes, and this is my time delay. This is my output, what I'll get. Yes, so we have very simple blocks present in this. One is the charging unit, the other portion is the comparator portion, and other portion is the output portion. So these three blocks are indicated only for the simple understanding of timer. Okay, it helps us to go into this complex circuit diagram of timer. That's why the simple block is introduced here. I'll move to the next slide. So now we have come to the pin diagram of IC 555. So this is also a very simple IC. It is a 8-pin IC where I have one ground and one power supply. Then I have, I want you to take to the previous slide. I have a trigger input. I have a reference input. I have a reset, and then one output. Yes, 3 inputs here and one output. So trigger input, output pin, my third pin is the output pin, and then my reset pin. Yes, reset pin is the input pin, and I have one pin for control voltage, one pin for threshold voltage, one pin for discharging the capacitor and charging the capacitor. So that the control is given to the external circuit to discharge the capacitor and to charge the capacitor. So it's a very simple pin diagram to understand. One is ground, one is power supply, and we know the block diagram is having 3 inputs, that is trigger, reference, reset, and one output pin. So this is the output pin, and trigger input pin, and reset input pin, and as well as the other pins of control voltage, threshold, and a discharge. I hope it's very easy for you, all of you, to understand. So any queries is there, any doubt is there, just post it in the chat box. I'll reply to that. Yeah. Um, it's not that much complex as you see here. It's very easy. I'll take you through this block diagram. We will see block by block what it is. So this purple color block is the potential divider block. So I have three resistance. So what is this? This is my IC 555. See, this is my IC 555 IC integrated circuit. So inside I have this 8 pins, 6th pin, 2nd pin, ground pin, VCC, control voltage, reset, discharge, all these are present over here. Okay, so how the IC looks internally, the internal structure of the IC is shown here. Okay, now we will see what is this. Once this is clear, we can very easily understand the modes of working of timer. Yes, we have the potential divider as a purple color. So three resistors are present here in this, and then two comparator blocks. So we all know what is a comparator. The comparator compare two things. So we will also always compare two things. No, any two things. Which cake is having more weight? Which chocolate is so much sweeter? We will compare the two things. So similarly, this comparator also do the same thing. Yes. Then this is the flip-flop block. So those who study digital electronics will be aware of this flip-flop. I'll also once recall what is flip-flop. Okay. Then we have one transistor, simple transistor. This transistor will help us to charge the capacitor and as well as to discharge the capacitor. And one buffer output block is connected. What is coming here will be passed to the output side. That is a buffer output block. Okay. I want your concentration on these 2 points. See, the positive of the comparator is connected to the potential divider where we have the voltages 1/3 VCC. Then the other point of this comparator is connected to one potential divider where I have the voltage of 2/3 VCC. So here I apply the VCC. VCC is supply voltage. So how much supply I can apply here? I can apply from the level of 4.5 to 18 volts max. I can apply to the timer IC. So my VCC can be 4 volts to 18 volts. Anything I can take in my VCC. Then 2/3 will comes to this comparator. 1/3 will comes to this comparator. Yes. So this comparator, the other input is trigger. When I trigger, it triggers something. Yes. When I trigger, it will trigger some operation in this circuit diagram. Then this point is threshold point. Let us see what is threshold point. Okay. So up to this, is it clear? Am I audible? Can you able to follow? Okay. Okay. For threshold, see. Okay. Let us resume. For threshold, if the threshold voltage is greater than 2/3 VCC, this point is threshold and this point is 2/3 VCC. It will compare the threshold point and 2/3 VCC. At any time, my threshold point, the voltage in this point is greater than 2/3 VCC. What happens? This comparator output will turn to 1. Participants, please follow. It's a sequence. The same will be repeated for all the modes of application, monostable as well as astable. Yes. Uh, so it's also given in the statement here. When threshold this value, this voltage value is greater than 2 by 3 VCC at any point, this comparator goes to on state. That is, it will release one output. If this output is 1, it is connected where? It is connected to the R of the flip-flop. That is reset of the flip-flop. And as well as this point is trigger, and this point is 1 by 3 VCC. Whenever the trigger is greater than 1 by 3 VCC, then this comparator goes to on state. Yes, we are just discussing when the two comparator will goes to on state. So one input is threshold, the other input is 2 by 3 VCC. When it will compare the two inputs, when this is greater than this one, threshold is greater than 2 by 3 VCC, at the time this goes to on. Yes. So flip-flop, so this is SR flip-flop. So S is for set flip-flop. Any idea what is SR flip-flop? Any idea what is SR flip-flop? Okay. Okay, very good. Set or reset flip-flop. Flip-flop. Yeah, we know flip-flop model phone, but what is flip-flop? Flip-flop is it will change its state. Flip-flop, that is 1 0 1 0. It will keep on change its state. That's why it is flip-flop, and here it is set or reset flip-flop. When I give 1 to yes, the output Q will be 1. When I give 1 to yes, when I want to set the flip-flop, I'll give 1 to yes. So output Q will be 1. When I want to reset the flip-flop, I'll give R as 1. If R is 1, the output Q is equal to 0. Yes, correct. When I give S is equal to 1, it means that the flip-flop is set. So Q will be equal to 1. When I give R to when I give 1 to R, the flip-flop is reset so that the Q will be equal to 0. Yes. So here I have Q and here I have Q bar. If Q is 1, obviously Q bar will be 0. If Q is 0, obviously Q bar will be 1. Yes. The same is given in the truth table. If S is 1, if S is 1, what is Q? Q is 1. So we call flip-flop as set. If R is 1, Q is 0. So we call flip-flop as reset. Yes. So set flip-flop and then reset. How to set a flip-flop? How to reset a flip-flop? Yes, that's it. So we move to the different modes of using a timer. Yes, we have two famous modes present in timer. One is Astable Multivibrator and then Monostable Multivibrator. The very good example for Monostable Multivibrator is what I discussed in the very first beginning of my class. It is our biological timer. Yes, we set our timer. When tomorrow exam is there, okay, we will set our timer and we will place a trigger. We will give a trigger to our mind that I have to wake up exactly at 5 o'clock. So that is the trigger. Only on the exam day, I will wake up at 5 o'clock. In all other days, I'll be in sleeping mode. Yes. So when you apply a trigger, the device goes to on, and then after a particular time period, the device will automatically goes to off state. So that is the logic. We can understand using this example very clearly. So whenever you apply a trigger, the device goes to on state, and after a particular time period, it goes to off state. The iron box what we use in our home. So when you on the switch, the iron box remains in on state for a particular time, and then it goes to off state. Yes. Again, if required, the heat is reduced. Again, it will give one more trigger. Again, it goes to on state for a particular time. Again, it goes to reset state. Yes. So this is about the monostable multivibrator. Monostable multivibrator always needs a trigger to activate it. But astable multivibrator, no need of any trigger to astable multivibrator. So it will be keep on releasing on-off signals. So on, off, on, off, on, off. It will be keep on releasing the on-off pulses. So we can also call this as a square wave generator, or else a square wave generator, free running oscillator. These are the other names of astable multivibrator. Monostable multivibrator, the other name of monostable multivibrator is, it is one shot multivibrator. It is active for one time only. So it is one shot multivibrator. Yes, shall we move to the next slide? Okay. This is a very simple circuit. Once you are clear about the internal block diagram, internal structure, internal pin diagram of IC 555, then this circuit is very, very easy for you to understand. I'll just walk through the circuit. I'll start from this point. I'll start from this point. So, in the internal structure of IC 555, we had potential divider, that is three resistance, 1, 2, and 3. Three resistance we had, and we had two comparators, 1 and 2. Two comparators we had, and then we had a flip flop. Yes, it is a SR flip flop we have, and we had one transistor, isn't it? So here comes our transistor. Yes, is it is clear? So up to this part, is the internal structure of IC 555. The whole part is present inside your 555 IC device itself. Then what else extra I want to connect to work it as a monostable multivibrator? It is very, very simple. Which are all the external things? You are connecting one resistor and one capacitor. Only these two are the external components you have to connect to your IC 555 timer. Yes. So now you are familiar with what are all the components we use, where it is present, whether it is inside the structure, or which and all outside the structure. Yes. So now let us discuss its operation. So initially I'll discuss it with two part. The working I'll discuss with two part. Okay. Here up to this part is already present. Those who joined late, one more time I'll explain. This part is internal structure of IC 555. If you purchase a IC 555 timer IC, inside the IC itself, all this will be there. If you want to operate the timer IC in monostable multivibrator, you connect only this external resistor and one capacitor. it helps to charge and discharge. Yes, resistor and one capacitor. To start discussing about the working of this timer, to start discussing about the working of its timer. So first, I'll consider Q. Yes, we will start the working of this timer. First, initially, we are taking flip-flop output Q is equal to 1. Q is equal to 1. Initially, I'm just assuming, okay? It is not the actual state. I'm assuming that Q is equal to 1. If this Q is equal to 1, see that is connected to the transistor, base of the transistor. So the transistor goes to the on state. If the transistor is on state, then the capacitor will get a path to discharge. So the capacitor starts to discharge completely. Yes. So the first thing is the Q is on, Q is 1. So QD goes to on state, capacitor discharge completely. Yes. Now the monostable multivibrator is ready to receive any trigger. Yes. Now we know that the point 2 is the trigger point. Okay. So I apply a trigger now, and if the trigger, this trigger voltage will be compared with the voltage which is present in this point. So this point we know the voltage is 1 by 3 VCC. We discussed that in the pin diagram of timer IC, 1 by 3 VCC. So I apply the trigger here, and whenever the voltage of trigger go less than 1 by 3 VCC, this comparator goes to on state. If this comparator goes to on state, see it is releasing the signal reset. When R is 1, what is Q? Yes, when R is 1, Q is equal to 0. If Q is equal to 0, what happens to the transistor? The transistor goes to off state. Yes, correct. If transistor is off, then what happens to my capacitor? The capacitor will start to charge through the supply voltage via the resistor R. Yes. So the first of all, we have started our discussion like the transistor goes to on state and the capacitor discharged completely. Then later on, it went up to 0 volt. It's drained out completely. Later on, I applied some trigger and my trigger voltage go less than 1 by 1 by 3 VCC. So what happens? The comparator 2 comes into picture and it goes to on. It gives a reset signal to my flip-flop. So this reset Q will be equal to 0. So transistor goes to off state and capacitor goes to charging state. How long will it charge? It will charge up to the value present here. What is the value present here? It is 2 by 3 VCC. So how long my capacitor will charge? It will charge up to 2 by 3 VCC only. Once it reaches 2 by 3 VCC, this comparator will not be quiet. It goes to on state. If this goes to on state, it will release 1 to set. So it will give 1 to the flip-flop. When this gives 1 to the flip-flop, the Q will be equal to, yes, you are correct, it is 1. So if it is 1, again transistor goes to on state. So what you can understand from this, initially the transistor was in on state. The capacitor discharged completely up to the 0 point, and then I applied a trigger. So at that point, after receiving the trigger, uh, the comparator 2 comes into the picture, and it released a signal which made Q to 0. If Q is 0, the transistor goes to off state and capacitor starts to charge. Yes, only up to a particular time period of 2 by 3 VCC. After that, again, the capacitor 1 comes into the picture and it released the set signal. So if you apply a trigger up to a particular time period, Q bar, which is Q bar, our output is connected to Q bar. So if I apply a trigger up to a particular time period, until the time period my capacitor starts to charge up to 2 by 3 VCC, only up to the time period I receive a output pulse. Then after the pulse, it is again goes back to sleep. Yes, once if you look little deep into the circuit, it will be very, very clear. I'll share you this PPTs. I have given the clear instructions, clear points how to go through this, work through this. So it will also be very clear for you. Because I have my own timer, the time allotted me is only up to 12 o'clock. So I don't want to take other percentage time also. So it is. I apply a trigger which is less than 1 by 3 VCC. So the capacitor was initially went to the 0 voltage. Again it started to raise up to 2 by 3 VCC. So the output pulse is available only up to the time period. Again it goes back to sleep. So how much time it is on? You can identify that using this formula. P is equal to 1.1 into C1 into R1. Yes, using this formula, you can identify. Yes, so we'll quickly brush up what is duty cycle. This is our square wave pulse or any pulse on time, off time. This is my on time, this is my off time. So how long I have my on time, that that is my duty cycle. If 50% I'm on, then that is 50% is my duty cycle. If my on time is more, that is 70%, then 70% is my duty cycle. If my on time is 80%, then 80% is my duty cycle. Yes, so this is the, so we have seen a very complex diagram here, no? This is the simple diagram of what we have seen in the old slide. So what I have connected, only the external resistor, sorry, only I have connected the external resistor RA and then one capacitor. Yes, all other circuits are present inside the timer itself, so no need to worry about that. Once you know the operation of timer, you can design your own circuits using timer 555. When I apply the trigger, the output goes to 1. After a certain period, automatically the output goes to 0. Okay, next we will go to the application of pulse width modulator, application of monostable multivibrator. So this is my trigger. In previous case, I applied only one trigger, but here I am applying so many triggers. I am continuously applying my triggers. Yes, and this is my threshold voltage. My threshold voltage is now not 2 by 3 VCC, but here this is my threshold voltage. My threshold voltage always changes. So what is my output voltage? My output voltage is also not the specific time what I stated here. My output voltage is also not be the specific time. The output time will also vary because my threshold voltage is not 2 by 3 VCC. My threshold voltage is always changing. Minimum, maximum, again coming down, still coming down, went to negative. Yes. So because of this, my width of the pulse is also changing. Yes. So what I have here, it is same, the timer is connected in the monostable multivibrator. So 2 is given for the trigger input, then capacitor for charging, R to charge the capacitor to maintain the time constant, and then Pin number 5 is connected to a, see, the sine wave input. The sine wave input is a modulating input. This sine wave input is connected to pin number 5. Okay. So what I connected to pin number 2, that is my trigger input. That is my trigger input. So what I'll get in my output? I'll get the pulse width modulator output. Yeah. Okay, this is still more easy compared to your monostable multivibrator. The only change what you have to do here to remember this circuit is connect these 2 points. Just tie those 2 points, that is the threshold and then trigger. So what is this point? This point is 1 by, this point is, sorry, this point is 1 by 3 VCC and this point is 2 by 3 VCC. Then now the other 2 points of the comparators are tied together. Yes, that is the only change we want to make in this, make to know the discussion of a stable multivibrator. All other things are almost the same. So we have the 3 potential dividers. Guys, I hope you can able to follow. We have 3 potential dividers, then 2 comparators, then 1 flip-flop, and then 1 discharge transistor. Then now I connected with 2 more resistors and 1 capacitor. So up to what and all will come inside my 555 IC? All this. Okay, no need to worry about the all these are already present in the 555 timer IC. Yes. Now we will discuss the operation of that IC. Okay. So in Astable Multivibrator, while discussing the concept itself, we discussed there is no trigger in the Astable Multivibrator. It is a free running oscillator. Once you switch on the multivibrator, it will be keep on running, and it will be keep on releasing the square wave output. So how it is doing so? See, this point is 1 by 3 VCC and this point is 2 by 3 VCC. Whenever my capacitor charge, increase to 2 by 3 VCC, then this comparator goes on. Whenever my capacitor discharges and come to 1 by 3 VCC, then this comparator goes on. Yes, is it clear? When the 2 comparator will go to on? When the capacitor charges and reaches 2 by 3 VCC, 2 by 3 VCC, this comparator goes on and then it will give S as 1, so Q will be 0, then when S as 1, Q will also be 1, so because of 1, transistor go to on state. Now the capacitor starts to discharge, but in monostable multivibrator, the capacitor will discharge up to 0 voltage. But here, the capacitor will discharge only up to which point? 1 by 3 VCC, because these two are interconnected. So it discharges up to the 1 by 3 VCC. Once that reaches 1 by 3 VCC, this comparator comes into picture. It releases the reset signal. If R is 1, Q goes to 0. If Q is 0, then capacitor goes to off state. If capacitor is off state, then if transistor is off state, then capacitor starts to charge via RA and RB. Yes. So this cycle will be keep on repeating, charging and discharging of capacitor. So that in the output part, I'll also keep on get a square wave output. Yes. I hope you all understand. The only difference what we do here is tie the 2 points, threshold and trigger here. There is no external signal applying. So the capacitor is charging up to 2 by 3 VCC and it is discharging to 1 by 3 VCC. Again charging, again discharging. So up to the charging point, the output is high, again it is low. Again it is high, again it is low. So duty cycle is equal to W is my on time. W is my how much time output is on, how much time output is high. So W by total time into 100. W by total time, on time plus off time into 100. That is my duty cycle. Hope you all are following. So this is the working, what I explained, that is given in words here. So Astable Multivibrator, see, all the structures what we discussed went into this pack, so no need to worry about those two comparators, flip-flop and transistor. The only thing you have to worry about is the external two resistors and one capacitor what you select. And from the basic principle of timer, we know that if these two resistors are high, then capacitor takes more time to charge. If these two resistors are low value, then capacitor takes less time to charge, so that I can control my charging and discharging time of capacitor here. Yes. So using this Astable Multivibrator, we are going to build a voltage controlled oscillator. Whenever I change my control voltage, I can change the frequency output. What is frequency? Changing the on time and off time. That is my frequency. Yes. So for the pin number 5, voltage control oscillator, for the pin number 5, I connected a potentiometer. I can able to vary the voltage by varying the pot meter. So if pot meter is varied, the voltage applied to control voltage I can able to vary. If control voltage I can able to vary, in turn I can vary the threshold voltage. So I can able to control the frequency of my on time and off time. That is the voltage control oscillator. So we have come to the end of my session. I have two questions for you. Whether you have understood this session or what? Just I'll read out the question. Design a circuit using 555 timer. It will flash the electric bulb such its on time will be 3 seconds and off time will be 1 second. So the 555 timer should on a bulb 3 seconds on and 1 second it should be 3 seconds on and 1 second it should be off. So you will put it into which mode? Please reply in the chat box. Which mode you will connect it? We discussed two different modes, na? Which mode we will connect it? Yes, very good. We will connect it in Astable mode. So Astable mode is a free running mode. I'm not giving any trigger here. It is the Astable mode. So this is the simple circuit given here. So Astable mode, how I can identify that is Astable mode? You can see pin number 2, that is trigger input, and pin number 6, that is the threshold input. Both are connected, tied together. So it is the Astable mode of operation. And the output is connected to the lamp via a relay. Okay. So for it, you can design accordingly for 3 seconds on and 1 second off. One more. Design a timer which should turn on heater immediately after pressing a button and should hold heater in on state for 5 seconds. Once I switch on, the heater should goes to on and it should be in on state itself for 5 seconds. Yeah, it's correct. It is the monostable multivibrator. So hope you all understood the session. Any queries, please post to us. Yes, hope it's clear for everyone. So this is monostable multivibrator. Why it is monostable? Because the trigger input 2 I connected to a switch. Okay, it is not tied with pin number 6. It is connected to a switch. Okay, so whenever you press the switch, the output 3 goes to on state, and it will energize the relay, and that relay in turn on the heating coil, which is already heater, which is already connected to the 230 volts of supply. Yes. So we have come to the last end of the end note of this topic. I hope you all understood uh, the basics of timer. What is timer? Where and all we can see timer. Uh, we can even design simple timers in different modes. Astable mode and monostable mode, and there are wide varieties of applications of timer. You can even google for some of the application, build your own simple circuit using breadboard, and you can test it. Yes, any queries are there, drop to me. So I have given shared my mail id to you. Yes, any queries, please post in the text box.